Study Unit 4. This presentation covers sampling theories, designs, and plans. In this presentation, you will learn the basics of sampling, the concept of error in the context of sampling, the factors to be considered when determining sample size, probability and non-probability sampling methods, the factors for determining the appropriate sampling design, and developing a sampling plan. Sampling involves selecting a relatively small number of elements, or sample, from a larger defined group or population, and expecting the information gathered from the small group will enable judgments about the larger group. On the other hand, under census, primary data is collected from every member of the target population. There are two types of errors, sampling errors and non-sampling errors. Sampling errors are any type of bias that result from mistakes in either the selection process for prospective sampling units or in determining the sample size. Non-sampling errors are bias that occurs in a research study regardless of whether a sample or census is used. For example, bias caused by measurement errors, response errors, coding errors, and etc. Probability sampling is a technique of drawing a sample in which each sampling unit has a non-probability of being included in the sample. There are four major types of probability sampling methods: simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling. Non-probability sampling means the probability of selecting each sample unit is unknown. There are four major types of non-probability sampling, including convenience sampling, judgment sampling, quota sampling, and snowball sampling. There are a number of differences between probability and non-probability sampling methods. For example, in terms of the list of population elements, for probability sampling, a complete list is necessary, while for non-probability sampling, it is not necessary. For sampling scale required, probability sampling requires strong sampling scales, while non-probability sampling requires little scales. For cost per unit sampled, probability sampling has moderate to high cost, while non-probability sampling has low cost. For estimates of population parameters, probability sampling method is unbiased, while non-probability sampling method is biased. For measurement of sampling error, there are statistical measures for probability sampling methods to estimate the sampling error, while for non-probability sampling, no true measure actually available for measuring the sampling error. Simple random sampling is a method of probability sampling in which every unit has a known and equal chance of being selected. While systematic random sampling is a method of probability sampling in which the defined target population is ordered and the sample is selected according to the position using a skipped interval. There are 5 major steps in drawing a systematic random sample. First, obtaining a list of units that contain an acceptable frame of the target population. Second, determining the number of units in the list and the desired sample size. Third, computing the skip interval. Fourth, determining a random start point. And last, beginning at the starting point, select the units by choosing each unit that corresponds to the skip interval. Stratified random sampling is a method of probability sampling in which the population is divided into different subgroups and samples are selected from each. There are three basic steps in selecting a stratified random sample. First, dividing population into homogeneous subgroups. Second, selecting random samples from each stratum. And last, combining samples from each stratum into a single sample. There are two methods of deriving sample from strata: proportionate or disproportionate. In proportionate stratified sampling, the sample size from each stratum is dependent on the stratum's size relative to the defined target population. Therefore, the larger strata are sampled more heavily because they make up a larger percentage of the target population. In this proportionate stratified sampling, the sample size selected from each stratum is independent of that stratum's population of the total defined target population. This approach is used when stratification of the target population produces sample size for subgroups that differ from their relative importance to the study. Cluster sampling is a method of probability sampling where the sampling units are selected in groups rather than individually. There are 5 major steps in drawing a two-step cluster sample. Step 1. Obtain a list of potential sampling units that contain an acceptable frame of the defined target population elements. Step 2. Use some type of secondary information or past experience with the target population. Select a stratification factor for which the population's distribution is skewed and can be used to determine that the total defined population consists of separate subpopulation of elements. Step 3. Using the selected stratification factor, segment the defined target population into strata consistent with each of the identified separate subpopulations. Step 4. Determine whether there is a need to apply a disproportionate or optimal allocation method to stratification process. Otherwise, use the proportionate method and then estimate the desired sample size. Step 5. Select a probability sample from each stratum using either SRS or SYMR's procedure. Under non-probability sampling methods, there are 4 major types: convenience sampling, judgment sampling, quota sampling, and snowball sampling. Convenience sampling relies upon convenience and access. Judgment sampling relies upon beliefs that participants fit characteristics. Quota sampling emphasizes representation of specific characteristics. And snowball sampling relies upon respondent referrals of others with like characteristics. There are 7 major factors to be considered in sampling design, including research objectives, degree of accuracy, resources, time frame, knowledge about the target population, research scope, as well as statistical analysis requirements. Factors affecting the sample size, including variability of the population characteristics under investigation, the level of confidence desired in the estimates, most often 95%, the degree of precision desired in estimating the population characteristics, and others such as formulas and rules of thumb. A sampling plan specifies the process used to select sampling units from the population. There are 7 major steps in developing a sampling plan. First, define the target population. Second, select the data collection method. Third, identify the sampling frames needed. Fourth, identify the appropriate sampling method. Fifth, determine sample sizes and contact rates. Sixth, create plan for selecting sampling units. And last, execute the plan. To summarize, in probability sampling, each sampling unit in the defined target population has a non-probability of being selected for the sample. In non-probability sampling, the probability of selection of each sampling unit is not known. Therefore, potential sampling error cannot be accurately known either. A sampling plan is the blueprint or framework needed to ensure that the data collected are representative of the defined target population. Reflection question. Singtel is interested in determining the heavy users of mobile phones. What type of sampling method would be the best suited for this situation and why?